Alright, we're going to do the arc length of a parametric curve. For the parametric curve, x equals 3t squared and y equals 2t cubed, as t is greater than or equal to 0 and less than or equal to 2. So for arc length, our equation is the integral from a to b of the square root of the x of t, the derivative of x of t squared, plus the derivative of y of t squared dot. So plug in our values. Well, let's actually find x prime of t. So we're going to take this 2, multiply it out front, so we have 6t. Then y prime of t. You're going to take 3 times 2, which is 6. And then minus 1 from the 3, so we'll have 2. So we got 6t and then 6t squared. So pretty simple. So we're going to square each side of these. 36t squared. 6t squared is 36t to the 4th. So we're going to have an integral. And to get our AB, here and here, we're going to go back to the original. You got from t0 to 2. So integral from 0 to 2 of the square root of 36t squared plus 36t to the 4th dot. If you guys notice, there is a 36t squared factor out of both of these. So you're going to have the integral from 0 to 2 of the square root of 36t squared times 1 plus t squared of dot. And if you notice, this 36, the square root of 36 is 6, and the square root of t squared is t. So we can take 6t out, and it'll leave us with the integral from 0 to 2 of 6t times 1 plus t squared dot. However, this 6 can be moved out front. So we'll have 6 times the integral from 0 to 2 of t 1 plus t squared, the square root of 1 plus t squared dot. But now how do we take the integral of this? Well, this is a simple u sub for this, for the 1 plus t squared. So we get u equals 1 plus t squared. So we take du. So it's 2t dt. Now we don't have that 2, so we're going to have to divide by the 2. So our 6 is really going to be 6 over 2, so that's 3. So we're going to have 3 from the integral. Now we got to change our bounds. I got to plug 0 and 2 into t for u. So for u, for t equals 0, we'll have 1 plus 0 squared. So u is going to equal 1, so 2. When I plug 2 in, we'll have u equals 1 plus 2 squared, so 1 plus 4 equals 5. So from 1 to 5, the square root of u du. And remember, square root of u is equal to u to the 1/2. So I'm going to rewrite it like that. 315 u to the 1/2 du. So integral of this. This one's easy now. We're going to have 3. Well, you add 1 to the power, so we're going to have 3 halves. Divide it, so we're going to have 2/3. Now notice these 3's here will cancel out. And we'll have 1 5. So we'll have 2u, 2 times u to the 3/2 power. So we could take this 2 out front. Doesn't matter. So we'll have 5s to the 3/2 power. So when you have a 5 cubed and you take the square, you really have 5 times 5 squared. All that squared. So you could take this 5 out here, this 5 squared out. So you have 5 to the times 5 halves minus 1 to the 3/2, which is just 1. So you are left with 2 times 5 to the 5 halves, 2 5 halves, 2 5 root 5 minus 1. And you could multiply this in. So you have 10 root 5 minus 2. Honestly, this is how I'd leave it. With the 10 root 5 minus 2, or 2 times 5 root 5 minus 1. And this is our overall arc length.